Hello viewers, you are very welcome back to the channel again. Tyndanius Maths and Science Tutorials. Today we are going to solve questions. We are still in the normal business of solving questions on gas laws. We want to appreciate the relevance of these gas laws. So the question reads, at 30 degrees Celsius and 760 millimeters of mercury pressure, a gas has a volume of 20 cm cubed. Calculate its volume at 730 millimeters of mercury at 40 degrees Celsius. Before we proceed with this, let's do one or two recap. Now, remember that in ideal gas equation, please, if this is your first time, you can visit my previous lectures on ideal gas equation. Everything is explained very, very well. So, in ideal gas equation, we said that PV is equal to nRT. Just in case you are giving the mass and the molar mass or what have you, N is equal to M over the molar mass. And out of this formula, we had P1V1 over T1 N1 equals P2V2 over T2 my N2. This is the molar gas equation. So out of this, we had this. Now we have another equation we call the general gas law, the general gas law equation. For the general gas law equation, it encompasses Boyle's law and Charles' law. So if I have Charles' law and Boyle's law only, this equation becomes P1 V1 over T1 equals P2 V2 over my T2. You know that this N, they are here because of Avogadro's law. Avogadro says that the volume of the gas is directly proportional to the number of what? Of moles. Do you get it that way? So the N is here because of the Avogadro's law. So to throw more light on this, I'm saying for the general gas equation or laws encompasses what? Charles' law and what? And the Boyle's law. So Charles' law states that V is directly proportional to what? The absolute what? Temperature. And the Boyle's law also says that V is inversely proportional to what? The pressure. So V and V, they are the subjects of the formula or the relation. So therefore I can say V is directly proportional to, what do I have? Directly proportional to what? T. Then I have here over P. So my over P will come here. When I introduce a constant over here, I have V equals, then I have my constant, which is what? My K. Multiplying this T all over the denominator, which is what? My P over here. So the constant of variation, the constant I've introduced will multiply this T. That's why they are multiplying over my denominator. Now, when I cross multiply, 1 multiplies the whole of this, so I will get KT is equal to P times V will give me what? PV, right? Now, when I divide both sides by T, when I divide here by T, T cancels T, right? So therefore, my constant is equal to what? PV over T. So therefore, I can say this PV over my T is equal to K, where K is what? My constant. What is constant? I can therefore repeat the same. So I can say PV is equal to T, which is equal to constant. This should remain constant, it shouldn't change. So PV over T. So P1, V1, T1, then here will be P2, V2, and T2. So that's the reason why we are saying that. Do you understand that? So in the absence of number of molecules, you can just employ this formula. Based on the question, the data you can fish out from the question will depict the formulas you are supposed to use. So let's see what happens here. At 30 degrees Celsius, so my temperature 1 is equal to my 30 degrees Celsius and 760 millimeters of mercury. That is my pressure 1 is 760 millimeters of mercury. Remember, I'll change this to Kelvin. So this will be 30 plus 273, which is equal to 313 Kelvin. Good. Then it has a volume of, so that is my final volume of the V2, which is equal to 20 cm3. No, that is my V1, sorry. And a gas has a volume of 20 cm3. Yes. As I calculate its volume, so this is my new volume, which is my V2, of which I don't know, at 730 millimeters of mercury. So that would be my pressure 2, which is equal to 730 millimeters of mercury at 40 degrees Celsius. So my T2 will be what? 40 degrees Celsius. So in Kelvin, it will be what? Punch it to the calculator for me. 40 plus 273 for the temperature 2.
The first one is 303, this one is 313. 313.
So 313.
Sorry, that's the mistake.
And where this one is what?
303.
Okay, 303 Kelvin. Thank you. So let's employ the formula. Clearly, you can see that I can use the general gas equation, which says that P1 V1 is equal to P2 V2 over T1 then over what? T2. So what am I looking for? V2. I can make V2 the subject. I might make V2 the subject here. I'll get V2 is equal to P1 V1 T2 all over P2 times T1. So by substitution, my P1 here is giving me 760 millimeters of mercury. Please, the reason why I didn't change the unit for the pressure is the millimeters of mercury. You have pressure here. The unit will cancel out, so no need for me to do any conversion here. Times my volume. My volume here with V1 is what? 20 cm cubed. Times my T2. My T2 here is what? 313 Kelvin all over. My P2 here is what? 730 millimeters of mercury multiplied by T1. From the question, you have 303 Kelvin. So millimeters of mercury becomes millimeters of mercury. Please, when you punch this into the calculator, what are we getting?
21.5
centimeters cubed. So this is my volume 2. So calculate its volume at. So that is the answer for the first question. Let's attempt the second question. I say a gas occupies a volume of this. So that's my V1 is equal to 400 cm cubed at 0 degrees Celsius. So that will be my T1 at 0 degrees Celsius. I'll convert it to Kelvin, which will give me 273 Kelvin. And 780 millimeters of mercury. So that will be my what? My pressure at 780 millimeters of mercury. What's volume? In liters, so I don't even know the new volume, will occupy at 80 degrees Celsius. So my T2, which is equal to 80 degrees Celsius, in Kelvin will give me what? With the help of the calculator,
that's 353.
353 Kelvin. Thank you. Then finally I have my final pressure, which is pressure 2, which is equal to 780 millimeters of mercury. From the question, it's here 780, the final temperature, the final pressure,
Yes.
and this one too is 78 millimeters. Okay, so pressure 1 and pressure 2 here, according to the question, they are the same. So we are finding for V2, right? So V2, we'll make V2 the subject. You have P1, V1, T2 over P2, T1, which is equal to, by substitution, you have 780 times V1, which is 400 cm cubed, then times T2. My T2 here is 353 Kelvin, all over P2. My P2 here is what? 78, then times my T1 is 273 Kelvin. So clearly this will cancel this because they are the same in magnitude. By the help of the calculator, V2 gives me what? They give me 2.
0.
Okay, give me.
Okay, 5.517.21.
51.21 C.
Centimeter cube.
Good. But the question is saying we should change everything to liters, the volume to liters. So what we'll do is you multiply our answer by 10 to the power negative 3, because 1 cm cubed is equal to 1 liters. So just multiply it by, so my V2 becomes 517.21 by 10 to the power negative 3 liters. And this is your volume for the question, because what volume the question specifies in liters, so we have to leave our answer in liters. Then the third question, let's see the solution to the third problem. The question reads, find the initial volume of a gas at, so initial volume simply means V1 equals, of which we don't want to know, of a gas at 150 Kelvin. So we're very fortunate we're given the temperature in Kelvin straight away, so no need for us to convert. If the final volume, again the final volume to be what? 6 liters at this temperature of 100 Kelvin. So what is the new Kelvin? Just apply the Charles law. So we have V1 over T1 is equal to V2 over my T2. Because remember we said V is directly proportional to T. So that's how come we are getting this. So when I make V1 the subject, so V1 straight away is giving me V2 T1 all over T2. So my V1, by the help of the calculator, V2 here is 6 liters times my T1 here is what? 150 Kelvin over my T2. My T2 here is what? Is 100. So by the help of the calculator, what is my initial volume V1?
9 liters.
9 then liters. Why liters? Because the volume here is measured in what? In liters. So please try and listen to the voice of the question. Let's attempt the last question over here. So we have our solution. Given a container of lithium gas with an initial volume, so we're given the initial volume, so initial volume, which is V1, equals 277 liters, and temperature of, so I have my T1, which is equal to 77.5 degrees Celsius. So in Kelvin, what will you get?
That's 350.
0.5 Kelvin. Very good. So calculate the volume, so my new volume of which I don't know. If temperature is changed to. So my final temperature here, don't let the negative here scare you so much. So we have negative 82 degrees Celsius plus 273 Kelvin. So straight away we are getting what?
264.
264 what? Kelvin. 0.8 what? Kelvin.
Yes.
Kelvin. Very good. So let's do. So again, we can employ even the Charles law over here, where we know that V1 over the T1 is equal to V2 over the T2. So what am I looking for? I'm looking for V2. If I make V2 the subject, so V2 becomes V1 T2 all over by T1. So clearly my V2 becomes V1 is what? 277 times T2. My T2 here is now 264.8 Kelvin. All on my T1 from the question is what? Is 350.5 Kelvin. With the help of the calculator, when you punch, what are you getting?
209.27.
709.27. Then it's in what? Liters, right? Liters, the unit of measurement, liters. So therefore I will include my liters. So dear viewers, when you know the gas laws, you can solve a lot of questions. Just know how to write down your data and the formula will pop up in your memory. Thank you for watching. Comment, like and share. Bye.